Hello, this is Mr. Collier, and today we're doing some integrals of rational functions using inverse trig ratios. Okay, so we saw when we did differentiation that basically the derivative of a function like this gives you arctan, and the derivative of a function like this gives you arcsine. So we can use these relationships to set up these integrals, and these are in your formula booklet. So if you see a format like this, it becomes arctan. If you see a format like this, it becomes arcsine. Okay, you can prove that by simply getting the derivative of the right hand side, and you will get the left hand side here. Okay, so in the first question, we have this. We have a root in the bottom, so that's going to be arcsine. There's no 1 over a here, so it's going to be x over a, that kind of format. So it's going to be equal to arcsine of x over a. In this case, a is 3 because 3 squared is 9. And then, of course, don't forget the plus c. Okay, in the next example, again, we've got arcsine, but we don't have a 1 up there, so I can write it as 3 times the integral of 1 over root 1 minus 2x squared dx. So that's going to be 3 arcsine 2x plus c is the integral of that one. Or is it? You should always check by finding the derivative. Notice if you find the derivative of this function, you got to do an extra multiply by 2 because of chain rule, right? So you get 2x here is the argument of arcsine, so you have to be multiplying by 2 if you find the derivative. So when you find the integral, you need an extra over 2 here, right? To counteract that. So watch out for that. The formula booklet only has if it's just x. So if that's like a 4x here, then you need an extra 4 here. If this is like a 2x, then you need a half in front of the arcsine. So be very careful of that. Okay, let's move on to the next example. And this one is going to be simply, well, this one's actually easier than the previous one. It's arcsine of x over 2 plus c. And in this last example, we don't have the same format as before, but sometimes in these more complicated questions, we got to think about how do we get the right format. So it looks like, well, there's no surd, so it can't be that one. But if we can make it look like x squared plus a squared, then we can use arctan, which we can if we complete the square, right? So let's complete the square over here. So remember, completing the square involves writing this as, well, half this number squared is 4. So we need this, and I guess we have that if we split it like this, right? So I just split it like this, and this becomes x plus 2 squared plus 3. So this is the same as the integral of 1 over 3 plus x plus this squared. And let me further clarify, this needs to be a square number to use that tangent integral rule in your formula booklet. So this is like root 3 squared plus x plus 2 squared dx. Okay, and then in the formula booklet we have, we have 1 over a arctan x over a. So that's what this becomes. It becomes 1 over a, so that's 1 over root 3 arctan. In this case, the x is x plus 2, and it's going to be over root 3 plus c is the integral.